Hello, my name is Rachel, and I'm a sound designer for games. Today we'll be looking at the various methods that I use to implement environment audio in Unreal Engine 5. Similar to the previous video that I did on Footsteps, I did one version of the project using Unreal Audio and one using Wise. But because of how many topics there are to cover, I'll only be talking about the Unreal Audio version in this video. I'll be making a follow-up video in the future to talk about how I did all of this in Wise. I've also added timestamps in the description in case there's a specific topic you'd like to skip to. Before we dive into the implementation, I wanted to take a moment to talk about where I got the environment that I used for the project. There are a huge variety of fully built environments, including many for free on fab.com, which is Epic's asset marketplace. Every month, there are different assets that are available to download for free, often including an environment with a fully built demo level. You can also go to the Environments tab and filter by free products as well. The one that I used is called the Downtown West Modular Pack by Pure Polygons, which is linked in the description. There are two things I would keep in mind when looking for an environment to work in. First, make sure that what you're downloading is compatible with the version of Unreal Engine that you'd like to use. Second, you may need to add a player character to the level on your own. If you do, an easy way that I found is to start with a fresh third-person project, and then import the assets you downloaded into it. Once you've done this, open up the demo level and add a player start. You should be good to go when you press play. The first thing I did was to plan my approach for how I wanted to create the sounds. I started by running around the world and writing down any potential opportunities for cool audio moments. One thing I noticed is that it felt like there were distinct areas within the environments. I came up with a concept for each of these zones and began creating a rough asset list for each. Afterwards, I came up with a list of systems that were needed to support the vision I had for each zone, and decided to build up the soundscape by working through each of these systems. Since I had worked on implementing Footsteps recently, I thought this would be the easiest place to start. I used the same method that I talked about in the video here, so I'll go through this process quickly. I recommend taking a look at the video for a more in-depth look if that's something you're interested in. During the walkthrough of the level, I created a list of different surfaces and mapped them against the most commonly used materials. From there, I created physical surfaces for each of the surface types I had identified, and added them to each of the materials. I also noticed that some surfaces had puddles and shrubs on them that the player could walk through. We'll come back to this in a bit. Afterwards, I moved on to prepping the player character. There were already sockets for the feet that I could use, so I added audio components to them and double-checked the anim notifies that were on the animations. From there, it was time to set up the meta sounds. I used a pretty standard setup that randomizes the file played, pitch, and volume, and added a section to be able to layer puddle splashes or leaf movement on top of any footstep. The volume of these layers is set through control buses, which we'll go more in depth into the setup of. The last step was to turn this meta sound into a preset that I could use to quickly set up all the sounds for the surface types. With the meta sound set up, the last step to get the footsteps working was adding a new function to the animation blueprint. This uses a line trace to detect the material of the surface under the player and use that information to play the appropriate meta sound on the player's feet. One quick note here. I ran into an issue where the material wouldn't switch correctly when the player ran over a static mesh with multiple materials, like the planners that have both brick and dirt. It turned out that a trace will normally only return the first material listed on the static mesh. To have it return the exact material underneath the player, you need to check the trace complex box. As I learned, the default trace is based on simple collision, while the complex trace is polygon-based. To go back to the planter example, the default trace will hit the planter, see that there's one big object, and only send back the first material. It doesn't care about the individual parts, it only sees that it hit a big static mesh. A complex trace, while more expensive, will instead return the material of the specific part of the planter that it hit. Speaking of collision, let's take a brief detour to talk about the system being used to detect if the player is stepping into a puddle or a shrub. Let's start with the puddles first. One of the immediate issues I noticed was that the puddles don't have a specific mesh associated with them. They had actually been painted directly onto the texture. After doing some research, it looked like it would be possible to detect the painted-on puddles using C++, but since I wanted to stick to using blueprints, I needed to find a different solution. What I ended up doing was using modeling mode to draw a static mesh around the puddle. I want to acknowledge that this isn't a sustainable solution, especially on a large game, but it does work for a small solo developer project like this. Going a bit more into detail, I specifically used the Polygon Extrude option to be able to easily draw around the outside of the puddle. I needed to be tall enough for the player to collide with, and I also needed to make sure that it intersected with the ground properly after drawing it. I added collision to the new static mesh and put an invisible material on it. I also added a puddle tag, in addition to creating a trace channel and collision preset unique to the puddles. I repeated this process with every puddle I could find in the level. Once that was done, it was time to set up the blueprint. I used an on-actor begin overlap event in the third-person character blueprint. To give a quick description, if the player overlaps with something and the blueprint sees that it has the puddle tag, it sets the control bus value that turns up the puddle layer in the Footstep meta sound. The control bus value is reset when the player stops overlapping with the puddle. As you probably saw, there's some additional logic in the blueprint for setting the volume of the shrub layer in the Footstep meta sound. Let's talk about that now. After doing a lot of clicking around the project, I realized that all of the shrubs had been painted in using the foliage brush. I found out the hard way that the normal static meshes of the shrubs and the shrubs created through the foliage brush have two completely different sets of collision settings. This was very similar to the issue I ran into with the procedurally generated foliage in the Footstep project I worked on. To add the proper collision settings, I needed to go to the foliage brush menu, select the shrubs, and adjust the collision settings there. I wasn't able to add a tag to them, so instead, the blueprint checks to see if the shrub is part of the instanced foliage class, and if it is, it plays an initial sound to represent colliding with the shrub, and also turns up the shrub layer in the Footstep meta sound. The shrub layer is turned back down in the same on-actor end overlap event that also turns down the puddle layer. And with that, we finally have our footsteps fully functioning. From here, let's move on to creating the background ambience using Soundscape. Soundscape is a super cool plugin that allows you to quickly build up an ambience through the use of colors, which are sounds that can loop or play randomly at different locations around the player. For this project, I wanted to use it for any background sounds that would work for the environment but didn't necessarily need to have a specific location. I wanted each zone to have its own color palette or set of sounds that would swap as you walk around the town. Let's go through the setup first. To use it, you need to add it to your project in the Plugins menu. The next step is setting up the gameplay tags needed to be able to swap between color palettes when moving between zones. I started by creating a new data table and adding a tag for each zone. Afterwards, I created corresponding color palettes and added them to the project settings with the appropriate tags. With the data portion set up, I now needed a way to mark the zones on the map so that the tags change as the player walks around. To do this, I used the same Polygon Extrude option from the modeling mode to draw in collision volumes. Since the zones aren't all rectangles, I used Polycut to remove areas from certain zones to get the exact shape I was looking for. Afterwards, I added all the collision volumes to the level blueprint to be able to set up collision events. The event itself is super simple, and is mainly just a node to set the correct soundscape state or gameplay tag for the zone. One thing I learned by playtesting is that if you don't clear all the previous states, they all begin to stack. To get around this, I have a string of clear state nodes that remove all the previous states before setting the new one. With the states set up correctly for each zone, it was time to set up the color palettes. For the individual colors, I used a combination of metasound presets, which included one metasound for background loops and another for randomized one-shots. Because a lot of randomization was already being handled in the metasound itself, I primarily focused on setting up the spawn behavior for each. Getting to the final values was honestly just a lot of trial and error. I would playtest, walk around the zone, stand still for a bit, and then make adjustments based on how things are feeling in-game. I repeated this process for each zone, covering the background and middle ground sounds I had identified during planning. One specific color that I wanted to take a closer look at was the one for the sound of wind moving through the trees in the forest. For this, I used the color point system. This is an additional feature of Soundscape that lets you play a specific color only if there are a particular number of objects with a specific gameplay tag around the player. I use this to make it so that the sound of the wind going through the trees only plays if there are a certain number of trees around the player, since there are areas of the forest that don't have any trees. Getting the color point system working was definitely one of the biggest challenges of the project for me. Before getting too deep into the setup, I wanted to give a shout out to Rhys for his Soundscape and color point system setup and demonstration video. This is one of the most comprehensive resources for getting the color point system working, and I used a lot of the same setup from his tutorial while working on this project. The tricky part of the color point system is getting the data about how many of a particular gameplay tag exist around the player into the Soundscape subsystem. From what I could tell, there are two ways to do this: using a component or using a trace. I started off by trying to use the Soundscape color point component since it seemed like the simplest method. You add the component to the objects you want to have counted, add the appropriate tag, and then set up a timer to have the check color point density node look for the tag every few seconds. Unfortunately, because most of the trees were instance foliage and I couldn't add a component to them, I had to use the trace method instead. For the trace method, I started by setting a timer so that the event would run every few seconds to check how many trees were around. We start by clearing out the data from the last check, and then do a multi-sphere trace around the player with a large radius. For this, I set up a specific trace channel that I added to the collision settings of all the trees in the foliage brush. Afterwards, the location of all trees found are put into an array. The information in this array is packed into a second array in a format that includes the appropriate color point tag and can be sent directly to the Soundscape subsystem. You might notice that there are two different branches in the first loop when adding the foliage locations to the array. This is because I realized that there are also normal static meshes being used for the trees in addition to the foliage instance ones. So I also needed a way to get the location of these and add them to the array as well. With this setup, I tested it in-game and adjusted the number of trees needed for the sound to trigger until it felt natural. Now that everything was set up and able to be playtested, the lack of reverb on the sounds was beginning to feel a bit more noticeable. Since I already had volumes drawn for each zone, I didn't want to have to draw a second set to be able to add reverb to them. Luckily, I found out about the volume proxy component. You can add these to any static mesh, and it will let you add effects to the audio while the player is within it. For static meshes, the proxy settings need to be set to primitive for it to work correctly. I added a reverb component and used the presets as a starting point, adjusting them while playtesting. I did this for each zone. There was one exception to not setting up new zones. While walking around the town, I noticed that there was a covered alley off to the side of the main street. Because I wanted the reverb to feel much more exaggerated there, I drew in another volume specifically for the alley. To make sure that it didn't conflict with the main street reverb, I set the alley's reverb to a higher priority level. The final thing to set up were emitters. I took the approach of having the emitters act as the foreground sounds, especially since they were the only sounds coming from a specific location in the world. I started with the easiest one, which was the fountain in the park. For this, I just dragged the meta sound into the world using the same looping preset from earlier, and then adjusted the location. I created a unique attenuation for most of the emitters, with the exception of the shops on Main Street. To get the correct attenuation settings, I did a rough visual estimation and made adjustments after listening to it in-game. A few more examples of emitters like this in the project are for the cloth tarps and drums in the plaza. The final step was adding the emitters to Main Street, which was where the majority of them were. With Main Street, my goal was to create small audio vignettes of what was happening at each store, so that it creates a picture of what's happening as you run by them. I started by creating a map of all the stores and putting them into different categories to see if I could reuse assets across any of them. From there, I made an asset list and slowly started adding the emitters to the scene. I ended up making a set of 3 different attenuations that I could apply to the stores based on the type. The snack stands got the tightest attenuation, while most of the shops got a medium-sized attenuation so that you could hear a faint version of the sound as you run by. A few of the cafes and restaurants were fairly wide, so to compensate for that, I made a larger attenuation so that you would hear the sound as long as you were standing close to where people would theoretically be seated. Most of working on this was playtesting and then making adjustments. With all the assets in place, it was time for a mix pass. I used the property matrix to help with making lots of volume changes at once. Much like the emitters, most of this was just running around, writing down notes, and making the adjustments afterwards. It was also during this point that I adjusted some of the fade-ins and fade-outs of the different colors, particularly the background loops, to help make transitions between zones feel smoother. And that was the process for creating the environment audio for this project. Thanks so much for watching.